Hello everyone, my name is Hasan Arif and today I am presenting on project Enhancing Mobility for Visual Impaired Person Using Deep Learning. Along with me I have Fazal Rahman Pasha and Ardak. Moving on to the next slide, I have outline for this presentation and it is as follow: problem statement and solution, data collection and data preparation, model training, results and future work. Moving on to next slide, we have problem statement and it is as follow. Around 3.2% of the world's population suffers from visual impairment. To assist these people, almost 3.2% of the population is more required, and which is not humanly possible. Rather than, we can build a virtual assistant using neural network model, which can provide assistance for enhancing mobility. Moving on to next slide, just on a lighter note, we have solution. Either you could have a superpower like shown in this image on the left, or you need assistance, which is shown in the right in the image. Moving on, we can combine superpowers along with the virtual assistance, and this is shown in this image. Moving on to next slide, we have a block diagram for our project and it is as follow. Problem statement, data collection, data preparation, model development and result. For problem statement, it is already mentioned, and for data collection, we took footpath pictures on the campus, and we prepared our data on RoboFlow, and we did the model development, and then we have the results. Moving on to next slide, we have RoboFlow, which is a tool for managing, annotating, and transforming the data sets for training. Moving on to next slide, we have the UI for the RoboFlow, and it shows the annotated image of the footpath. We use this tool in the RoboFlow to annotate our footpath, and this is the view of the image. These are few of the pictures of the data set which you can see on your screen. These all pictures are taken on campus.
Okay, so my name is Ardak, and I will be talking about model training. For model training, we use a YOLO V8, which uses transfer learning and using ResNet or Coco pre-trained models. So our neural network input will be an image, and the output will be the detected object bounding box. So to do the training, we use a Google Colab because our resources were limited, and so for that we RoboFlow provides very nice API to pull the annotated data from their cloud. So we use their API to pull the data set, and then we run the we run the train model. Then from the train model we got the accuracy and the loss. So as you can see in this slide, we run for 25 epochs, and you can see some of the results there. And here we have a plot of losses for train and validation data. So RoboFlow nicely divides the dataset to validation and training datasets. Then, as you can see in this image, it's a side note is that we have two projects in RoboFlow. The first project was only with a footpath. So the problem with that was the model was detecting footpath even in different in random images. So we needed to get the negative images, so we collected some negative images so the model can differentiate between the footpath and some random images. So for the results, I will let my teammate Fazal to speak.
Hello guys, this is Fazal Rahaman, and I'm going to talk about results. So after a long technical topic, everyone is excited for the results, right? So let's go. So the logic, we are dividing the input image into three parts. This is because a blind person can walk straight. If he walks straight, he should maintain the center of the footpath. If he goes to the left, there should be a voice command that should tell him to turn right. If he goes right, in the same way he should be he should get a voice command telling to go left. So this is how he going to maintain center on the footpath. Next, these are the few batch images of validation dataset and training dataset. Yep, so here is the video demo. As you can see, when the video is played, the centroid of the counter which is detecting the footpath is going on the left. With this is compared with the centroid of the input image. So whenever the centroid is on the left side, it actually tells you to go like turn right. If it goes onto the right, it actually displays turn left. So if he is just going straight, it actually tells you to keep straight. So this is how we were working on the conditions. This was the progress, and this is video like this. This is not the input from our camera. This is the video. So later on, in our after progressing this one, we have received we have done the code where it runs with the help of integrated camera of our PC, and this uses our GPU or CPU. So it doesn't matter if you have a good GPU or a bad GPU, this code runs. So as far as my laptop, I don't have any GPU. This code was using CPU, and as you can see in the output, it actually shows FPS as 1 or 2. This is just because my laptop is pretty old and it's using CPU, not GPU. So here in the video, we can see there is a footpath which is detected with 84% accuracy, 64% accuracy. Yep, and whenever I try to go left, it actually gives the voice command to turn right, and when I go right, it actually tells us to go left. And if it is maintaining center, there will be a voice command telling us to maintain a center, and you're maintaining a center. Yep. And as far as this, yep, this is the third person live demo with my laptop. Here I'm holding laptop and trying to walk, and as you can see in my laptop, there is a confidence level of the footpath, and you can hear in background a funny audio clip where it tells you to maintain center, like turn right and turn left. And as you're maintaining center, there are just few people shouting sheesh. That's it. So our conclusion and the future work, our conclusion is this is the best model as we have got. It can be worked a little bit more by providing a huge data set, and for the future work we can deploy this on the single board computers. It's like you just take the Raspberry Pi or and Jetson Nano, BeagleBone, other microcontrollers, and just integrate the camera and any speaker. So once this is done, you are if you want to maintain if you don't want to bump, or you want to maintain the for maintain the road or the footpathway, you could in attach or do sensor fusion with GPS, LiDARs, IMU. That's it, guys. These are the few references, and thank you very much.